Hey, so I'm going to start up. There's one other student who popped in and seems to have had that technical thing where they disappeared. And that will happen from time to time. I'm hoping that it's not an internet down situation. But the nice thing is, as long as my internet doesn't go down or Zoom doesn't go down, we'll have the video recording of class. So I'm going to start by sharing a screen like I always seem to do, and then I can't open the well, it my computer says I can't do a thing. We'll find out if I can do the thing. We'll try our best. So I seem to be sharing the screen, and it is recording, and so I'm viewing that as a good situation. I want to start with a couple of announcements and so we're all on the same page, and then turn it free to y'all because this is a class session where we're going to be doing review. You might have remembered from looking at the syllabus that there's an exam that's due July 3, okay? But yeah, literally the way I view it is because it contains material only through yesterday, Tuesday, general linear models in chapter 3. Let's talk about any questions you have, especially on the most recent material on the sample exam problems. And so we're turning the exam free into the wild as of 1 p.m. today. Take any time between now and when it's due, which is 11:59 p.m. on 2 days from now. So that's like Friday at just before midnight. I always recommend to students that they start the exam at least an hour before it's due. I mean, you got 2 days to do it. Starting at least an hour before it's due seems like easily manageable. And the reason I'm suggesting that is internet problems. Like there was that student who popped in and then popped out real quickly. Internet issues will happen. And if something like that happens during the course of the test, just let me know. We can work with it. Sometimes it might take me, half an hour or a day to get an email message, but all problems are solvable. We sort of learned that with classes during COVID, and I know that y'all are familiar with that. Sometimes there's good features, sometimes there's bad features. We live with the options that we are given. So I want to mention that do the test. The test is not exactly like the sample exam. The sample exam is designed to give you a collection of problems that are similar to those that I would be likely to ask of you. And so we'll spend some time today talking about that. But let's focus on the format now. I've got like a 50-minute test. I give you all 55 minutes to do it because I encourage students who are working on the test to effectively have a Word document open, take a screenshot, do a cut and paste in there. If you have something you'd want to write down, but you can't typeset it easily in Word, and please do not attempt to use Word's typesetting to make equations. If you're doing a calculation on paper, great. Just do it on paper. Take a picture and then incorporate the picture into that PDF that you're going to upload at the end of the exam. If and when answering a question, you say, "Hey, please see the handout." I'm going to look to your handout. It's a great way of knowing what you guys want me to know to help me grade your answer. In fact, I have some students who basically say, "See upload" for every single freaking question. In fact, they just put in the first question, "See upload" for every answer. And they just do the whole thing. They form a Word document, do some cut and paste, and answer every single question in that context. I don't know that that's always the best way to go, but I've had students who do it. I also have other students who don't upload anything at all, and that's also fine. I like tests to be sort of flexible that you should do what you think is right for you to answer the question. I provide data sets that match the problems. If I have a data set, right, that I use to create the problem, I will provide the data to you, and you should feel free to use JMP in any way you think is reasonable to answer those questions. Other students are going to say, I've got everything in front of me inside Canvas that everything that I need to answer the question. So I'm providing you what I think is sufficient for some of you to answer completely without using JMP at all, and others of you will use it a lot. The one thing I would want to say by way of advice is if you find yourself relying on JMP to answer questions, if you think, oh, well, I have to be able to figure out how to do the question with the software, you're probably misunderstanding the question or the reason for the question. JMP is meant to be a tool to help you get an answer or get to an answer, and that's about it. So that's what I have in terms of the format of the test. If any of you have questions, now though would be a real good time to ask questions about the format or style.
I have a question.
Yeah, Emma.
Um, so if the questions are written so that you don't necessarily have to use JMP, does that mean that the exam itself is a lot more conceptual heavy?
Or it could be I'll give you JMP output already. And for example, I might ask you to tell me the value of the test statistic in a particular context. Well, shoot, if I already give you the test statistic, you're home free. Or like one of our homework questions in regression asked us, it said, well, test the hypothesis that the slope is 4. JMP's output will give you a hypothesis test for the null hypothesis that the slope is 0. And you can, on pencil, with pencil and paper, sort of quickly redo this to test the hypothesis that the slope is 4. And so, yeah, there are some questions where you won't need JMP, or some students won't. Others will prefer to use it. Doesn't necessarily mean it's going to be conceptual, but yes, there are some conceptual questions. So I think I answered or attempted to answer the question, Emma. Would you like to rephrase?
Nope, that works for me. Thank you.
Okay. Yeah, yeah. Anyone else about the format or style of the exam? Okay, so what I want to do then is to sort of go back to the previous page and say something that I think matters to me, and that is if I were in your shoes as a student, I'm going to click my way into week 2, Wednesday, Thursday, the CD. Uh, yeah, week 2 CD. This summer 2003 exam review, July 6, 2023. That is pretty comparable to what I would want to do in class today, except there were A, more students in the class that term, and B, there were a couple of students who were particularly good at asking questions during a review session to help understand the content. And so I would certainly be watching that July 6, 2023 exam review before taking the exam. So I try to be really clear about that. That's not a hint, but it is a way of saying it's just a recommendation. How about we'll go with that? Okay. And if I sort of click my way into the exam 1 sample questions, and I'm just going to jump into the questions, the part without the answers. This is a sort of style that I would use if I were giving you a paper midterm. Your midterm is not going to be on paper, okay? And because it's not on paper, it will feel a little bit differently. But basically, think towards the end, there's these bluish colored questions, and there's 3 of them. Think your exam will be like 4/3 of this bluish test. Or if you look at the brown parts, which is 3 questions, your test will be about as long as 4/3. Like, so take the brown questions and add one more. Or if I look at the black questions here, there's 4 parts, 4 questions. Your test will be about as long as just the black parts here. So I'll call them black, brown, and blue if you want to refer to, like question 3. Tell me the color as well. But you can see some of the questions are largely conceptual because it's sort of like, okay, well, what if this is your question? Which of the methods would be used? So pick the method. Yeah. And then other questions are from past exams, and you might even see a question or two that you've seen in class. Okay. The data sets. And so it's just a matter of now. I would love to answer any questions that any of you have on the content of sample exams or in general related to material from chapter 0 or t-test, 1 ANOVA, chapter 2 regression, or chapter 3 the general linear model. And in particular, the way we parameterize things with the general linear model, the effects, if you will, are how different is this group from the reference group. And the reference group could be one of the particular groups. That's one style. But JMP by default will use the average of the group averages as your reference point. Okay, so I got time. You got questions. Let's do it. I do got to say, this is also the smallest Stat 313 class I've had during a summer term. And there's nominally like 8 people in class officially. And right now there's 4 of you here possibly asking questions. And so we can play this a lot of different ways, but maybe because none of you unmuted to ask a question promptly, I'm going to ask you all literally, have you looked over the sample exam questions yet? Please
Um,
let me
some of
go.
them, but not all of them.
Yeah, yeah, perfect.
I
And that's
have.
great.
Oh, oh, sorry.
Oscar?
Yeah, I was gonna. I have a question, and
Sure, sure.
I also looked through them. So for like the question one, we have like options
Yeah,
of like different things. So like the only one that's kind of stands out is like I'm a little rough on is like the Shapiro-Wilk test, and I also remember there's like a few
right.
other tests that you told us in like lecture or in the labs we had to use.
Yeah.
Would one of those replace Superior Wilk, or would yeah, or like can you just get like a review on that?
Yeah, so I love your question. It's really solid. So what I want to do is to list off, and I'm going to sort of switch gears here and darn it, there. I'm going to sort of draw it in here, and so like just work as though it's a whiteboard, and heck, I guess it is not only white, but in a classroom, it's a bigger whiteboard. This is reduced space, and I'm going to try and use a fine point on the iPad, so you're going to be able to. Be able to get more content here. So the various methods, and I'm just going to say, here's how I think about these situations. There's sometimes a hypothesis test. There's sometimes a corresponding confidence interval. And maybe if we just list off the situations and the names, we could write down the methods. Okay, darn it. Switch gears to erasing, which was not my plan. Okay, so there we go. Okay. What if we want to compare two means? Two means. That's sort of at the very beginning of the class. That's a t-test or the t-based confidence interval for the difference of mu1 and mu2. A confidence interval for literally how much higher mu1 is than mu2. 3 plus means we're going to use the ANOVA procedure or a Tukey post hoc procedure, sometimes called the Tukey-Kramer procedure. Okay, so 2 means use a t-test. We know that from that last class. If there's 3 or more means, you can't really use a t-test. And I guess if I'm saying 3 or more means we use the ANOVA. Well, literally, if you do have 2 means, you can use analysis of variance ANOVA to tackle the problem. but you typically would be preferring the t-test because that's what people do. Okay. What if you got a scatter plot and are fitting a trend line? It's going to be a hypothesis test in the regression context. It'll be a t-test again, but the t-test will have something like the sample slope be 1 minus a hypothetical population slope, and I'll call that beta 1, 0. Beta 1, the slope in the population, comma 0 for the null hypothesis case, and divide through by the standard error for that sample slope. A confidence interval, there's a couple different confidence intervals in the regression context. So in this regression context, there's a confidence interval for beta 1, the true unknown population slope. There's also a confidence interval for an average y for a given x. So literally beta 0 plus beta 1 times that x nu. I'll call that mu nu. There is a particular mean that goes with an average x. So the average of y for a particular x, you could get a confidence interval for that thing as well. And similarly, shoot, there's even a prediction interval for a new y, and I'll call that y new. So three different things that all sort of look like they're confidence interval styles. And so the question is really, are we asking you to predict an individual Y value? What is the GPA of someone at Cal Poly who studies 30 hours? If you tell me X is 30, yeah, I could tell you my estimate of the typical Y, but you would then want to have a plus or minus that's pretty big to correspond to, well, there's some error in my understanding of the average GPA of people who study 30 hours a week, but there's individual variability as well. And so give me a wider range. On the other hand, you might want to tackle a question about the slope. For each additional hour that you study, how much higher is the GPA tending to be? If Y is the GPA and X is the number of hours of study, then the slope tackles the question of how many more GPA points per hour of study do we have. So that's in the context of regression. Okay. I guess then that is getting after some of our methods and the context. We've also talked about Levine and Shapiro-Wilk, SW for Shapiro-Wilk. The Levine procedure is to test equality of spread across groups. So if you want to say, hey, is the spread the same across all the groups? That's the null hypothesis. Or is there a noticeable difference in the spread across our groups? That would be your alternative. Levine basically checks the standard deviation across the different groups. And if the standard deviations are dramatically different, Levine says, yeah, no, different spread. If the standard deviations aren't dramatically different across the groups, Levine says, yeah, it's reasonable to believe equality of spread. Shapiro-Wilk has, however, testing for normality. Okay, and so let's go with the pen. And we need to believe normality, and we need to have equality of spread in a lot of contexts. Equality of spread is necessary for ANOVA, so we could use Levine. You need normality for ANOVA as well. Again, use Levine. With regression, you want the residuals to have normality. Cool. Use Shapiro-Wilks to check for normality. And then for regression, to check for equality of spread, you don't really use Levine. There is a formal, actually, there's a whole ton of formal procedures to check for a lack of equality of spread in regression. Our book and my philosophy in general is just look at the scatter plot to see if it looks funnel shaped or not. Is there the same vertical spread of y, whatever the x is? Is there the same vertical spread in the residuals, whether the x is low, medium, or high? So I think, Oscar, I tried to get around all these different procedures that we talked about, and maybe I mentioned most, but not all of them. But yeah, with the different names, how do each of these named methods, when should I use them? That is really a good way to check your understanding of the material. So that was the plan. You want to follow up, Oscar, because I would love to answer a follow-up
Yeah.
question if you have one.
I
Yeah.
Oh, sorry, Emma.
no, you could go first.
I'm
You know, it's
sorry.
Oscar's question. I'll say, Oscar, you go first, and then Emma will follow up with her follow-up.
Yeah, I was just like, it's like for example, like I think question A, the answer was confidence interval for the initial plus B1x.
Yeah, yeah.
And so can you just clarify again what's the difference between that and the confidence interval for the slope? Guessing like
Yeah. Okay, so that's really the point on this question, and let me try and highlight what in part A causes me to say, oh, it's a this versus the other kind of procedure. Okay, so really, is there a relationship or not? Is there a relationship or not? Questions that are answered with a yes or no. Yes, there's a relationship, or no, there's not. Those are hypothesis testing questions. So if the question actually asks you about, is there a relationship? I would think hypothesis test. Second, is the number of hours studying related to the GPA? That's asking me about, is there a slope? A slope that's anything other than zero says there is a relationship. If one additional high school GPA unit causes a different average number of hours studied, you would say, oh, look, there is a trend. A trend is typically the alternative hypothesis, whether it's a t-test, an ANOVA, or regression so far. There is a trend. There's something intriguing. The hours studied is related to the GPA in high school. So that's why I'm thinking a test of the slope. And so let's figure out which of the methods that is formally. Some of you have looked it over, some of you haven't, but I'm saying this should be a slope test. And so which is the slope test? Oh, hypothesis test for the slope. So that's the reason I answered that on A. Um, I want to contrast though, because you raised the issue, Oscar. I'm glad you did. Uh, what about F? If a person has high school GPA of 4 versus 3, how much higher is the amount of study on average? That's also related to the slope. Why is it related to the slope? Well, a 1 unit increase in X is the slope. How much higher is the high school GPA in the how much higher is the hours studied in the 4.0s versus the 3.0s? We're saying how much higher is Y high school GPA on average for an increase in X of 1. So that's going to be well, it's related to the slope, but it's asking me how much higher. How much higher? Oh, how much higher? That is the slope itself. So a confidence interval for the slope is going to be the way to tackle part F. And let me, yeah, I'm going to go with that. I think that's a good way to tackle the question. So did I answer your question in part, Oscar?
yes, I probably have a follow-up, but you can answer Emma's first.
Well, if Emma's question's on problem one or something I said regarding problem one, perfect.
Oh, my question was regarding Oscar's question about like Shapiro-Wilks and stuff. So
Yeah, yeah,
for when checking normality of the spread of the residuals, do you mind like drawing out what exactly you mean by football shaped or box shaped, funnel
sure.
shaped and curved, just
Okay.
to kind of get a general sense of what those look like?
So I will describe that as not so much related to Shapiro-Wilk, which is more of a normality check, but rather equality of spread. So let's talk about residuals for a moment, okay? What do I do with residuals? Okay, so first off, I'm going to create them. Okay, so the residual, I'm going to term it EI. Literally, it's the actual data point, YI, minus my prediction of that data point. And indeed, that's YI minus B0 plus B1 times XI. And that B0 plus B1 times XI. That's just a way of saying, what would the trend line tell you Y should typically be for this X? Okay. We said that this is approximately equal to epsilon, the underlying residuals, which should be normal. They should not be predictable. They should have a mean of 0, and they should have the same spread regardless. And so we need to check normality and equality of spread. Okay, so how would I do each of those? Normality. I'm going to use, analyze the distribution to produce a histogram. And we could also go with a normal quantile plot. Or we're going to use then Shapiro-Wilk to check for normality. So there's 3 ways we could do that in the context of regression. So I would love to do that right now for you if you're okay with it.
Fine by me.
I love it. Okay, so I've got the data sets here open, and I'm going to go with the building heights and stories because I think we've looked at the data set already. So we've got data here on a collection of famous skyscrapers and the number of floors that the building had and how tall the building is. You'd think the height of the building might be related to the number of floors. Okay. I'm going to sort of do a fit y by x over here to say that the height may depend on the number of floors. Boom. Click OK. And my scatter plot over here suggests, oh, look, there is a trend. I could add in that trend line, okay? And the claim is the difference between a data point like this one here and what I would have predicted from the trend line based on just the number of floors. Like if I got 50 floors, I'm going to read up here. I would bet on about 650 feet, but this individual building at 50 floors was 845. It's got like a positive 100 residual-ish. So the vertical errors from that trend line is what we're getting with the residuals. I'm going to go ahead and save them. Save what? Save the residuals. And I get a new column over here. The residuals, my claim is they should be normal. So I have to look at to see if they are normal. So let's go ahead and try that with our analyze the distribution of what? Of those residuals. Boom. Go. Okay. And we have, well, shoot, I never like it vertical. I like it stacked. There is a way to turn on stacked as default. The problem with turning on stacked as default is then when I show you when it doesn't end up stacked and vertical, y'all as a group are like, why didn't it look right? So I just go with the default and then change it and then fuss at y'all every time. So normal, maybe. I could turn on the normal quantile plot, looking for a straight line. This looks pretty close to straight. Maybe it's like a little bendy right there and a little bendy yet again. So maybe there's a slight lack of normality. Let's find out what would happen if I check with Shapiro-Wilk. So I'm going to add a continuous fit, a normal curve to my distribution. Let's go look over here off to the left. And if I'm going to then use that continuous normal, that fitted normal distribution that we see over here, all I have to do is turn on this goodness of fit procedure. And my Shapiro-Wilk p-value says 0.2280. In other words, it's not a perfectly normal histogram, but it's not noticeably differing from normal. In other words, if I were to sample another collection of skyscrapers from a population that really was with normal errors around the trend line of the size that I did see, the same number of data points, like 30%, 20% of the time, I'd see a departure from normality as much as this blocky histogram is from the perfectly curved normal curve, or curvature in this normal quantile plot that's worse would happen only 20% of the time. It's easy for me to believe normality because we have no strong evidence against it. So that's normality alone. Okay, what about the other thing that you raised as an issue, Emma? And that is equality of spread. How do we check for the equality of spread? Well, let me write that out and then we'll go ahead and erase some things. Maybe I'll erase things first. You know what? There's got to be a way inside an iPad to erase like whole blocks or areas at a time. But I haven't discovered it yet. If someone knows, please tell me, because otherwise I obsess over this and I slowly erase and I could be wasting less time. Good. Okay, so besides the normality, we talked about equality of spread. And equality of spread of the residuals, because if the residuals have an equality of spread, then the underlying epsilons, which are the things we really need to have equality of spread, then that's reasonable to believe. And so what I'm going to suggest is a plot the residuals on the y-axis, and along the x-axis, you could plot just the x values. And so we're going to have some data points above, some below. And what we're really looking for is whether there's about the same vertical spread, whether x is low or medium or high-ish in value. This would be an example here of what I would call a box-shaped or a rectangular-shaped distribution. Same spread, whether x is low or medium or high. Let me move my friend over here, the data off to the right, and I'm going to show you another plot that we could see that would be called football-shaped. I'm sorry, not epsilon, but x. And if the data points are in a trend where they're always on an average 0, but there's some that are sort of smallish values for x or largest values for x, I'm not so worried. If there's only a couple that are on the small end, I'm saying I'm not going to say, well, there's only 2 data points, and so we're looking at a histogram. Let's go with a wider range of values, okay, for the x's. So whether the x's are small, medium, or large, is there the same vertical spread? Football shape corresponds to situations like we've got heights and weights, heights being the x value and weights being the y. There's going to be sometimes a couple really tall people, but only a couple, and a couple really short people, and again, only a couple, and that's going to cause a football-shaped histogram in some cases, not histogram, scatter plot, and that wouldn't trouble me. So Emma, do you want me to follow up with looking for that in the context of GMP's output and the residuals?
No, I think that answered my question. Thank you so much.
Okay. Anyone else want to follow up on something that came out of question 1? I think Oscar was still there.
Um, yeah, I guess just the for like I have 2 questions, but for question 1, um, part B, the
Yeah.
answer is confidence interval for B intercept that equation.
Yeah, yeah.
And yeah, so
Why
I
is
just
it
want to
that?
like, yeah.
So let's look here. What is the average number of hours studied? That sounds like it's asking me for a number, so I'm thinking it's got to be a confidence interval, yeah? And for what? Well, the average value of hours studied for a particular X. So I'm thinking this is telling me X knew a particular X that I want to know. Well, the average Y. So I'm thinking mu nu is what I want to know, the mu nu that goes with that particular X nu. You tell me an X, I want to know about the Y that goes with it on average. That's the confidence interval for the average of Y. So I guess in beta 0 plus beta 1 times X, you could write that as mu nu, a particular average Y for a given X.
Okay, I see it. Thank you.
Yeah.
And I think most question for right now. So on the syllabus,
Yeah.
obviously it's when you have like in class, when you have for in class, and for
Yeah.
the finals, it said that to have like a cheat sheet. And so I'm wondering how you want us to. Do you still want us to have like a cheat sheet? And if we do
I
we
love your
have?
question. So with the final exam, 8.5 by 11 piece of paper, both sides written on it. Yeah. That's the amount of notes you're welcome to bring to the final exam. We're all good with that. And for you guys, because it's a group of only 9 students, I'm going to be able to have you in the room and I'll just have you rotate your chair so I can like see and verify that none of you are cheating. And I'll just say, yeah, we'll treat it like a midterm, except for it'll be on paper, but you'll have access to the data and you'll have access to the computer and you could use the computer in any way you want. Mhm. But the difference between this test and then the final exam, like you suggested, might be that for this test, I'm not specifying anything about a cheat sheet. Normally in class, I do encourage students to bring 8.5 by 11 right on one side of it. I'm not telling you that. I would encourage you, however, to come up with a note sheet of sorts, 8.5 by 11, both sides, I don't care. But the reason for that is when you ask yourself questions like, what do I already know? What do I need to know? And where are those two different? Oh, I should put those things down on a cheat sheet. Or when you organize your cheat sheet, sort of like I tried to do earlier. Oh, two means or three or more means, or what if it's a scatter plot and we're doing a slope? When you organize your thoughts about what is the confidence interval, what is the hypothesis test in each of these different contexts, that organization is a great way of effectively studying or reviewing the material so you're going to know it better. The point of the cheat sheet isn't that you would have a note sheet during the test that you're going to refer to. The point of me encouraging you to do it is the fear of, well, what if I don't have it? Gets you to make this thing, and it's the making of the thing that has the benefit. So I don't know that I convinced you, Oscar, but I would hope everyone would spend at least an hour putting together a note sheet of all of the things I think I'm going to need and where can I find in the book those things, or where can I find in lecture notes those things if I'm stuck during the course of the test. You've got your own lecture notes that you wrote down, say, oh, see on page 12. Okay. And then on page 12, you got something circled in pink because you use pink highlighters, and you see page 12, pink highlighter. You're going to quickly flip to the portion of your course notes which are most relevant if you have that index. So the notes, view it as an index to your more thoroughly written out examples or class notes or whatever. So, Oscar, I hope I answered your question.
Yes, thank you.
Okay, someone else, because we got like 9 more minutes. Okay, so I'm just going to say you're here. You're not asking questions. I'll ask you a question, and maybe it will be helpful. Um, We had groups for lab work in week one. We've got groups for lab work in week two. It's always a pain in the ass for me to sort of like reshuffle people and stuff like that. But overall, are you finding that it's easy to work with people that you've been assigned into groups with either week one or week two? Do you know by now who you sort of click with and who you work well with by way of getting your way through the content?
Yeah, I say that it's working.
That's good. We love that. So Oscar also gives us thumbs up, same group, so that's easy. And now if Isabella sort of says no, then the two of them are going to be like, "Ah." Okay, cool.
Oh yeah, I'm happy in this.
So Nyla, you are not the same group as the other three who are here. Is there anything that you are saying to yourself that, yeah, I could benefit from something different? Just let me know. And you don't have to use names. I'm just saying I want to know if it's working okay or not.
I think it's fine.
I love that answer. Okay, cool. Well, this week, right around Thursday, I'm going to release another sort of survey of are you all good with groups, or do you have a recommendation or a preference for who you could be paired up with? Those sort of questions. And so far, I'm hearing you say, at least this time it's okay, and moving forward, then it'll be easier. And so I'll probably just for week three, it will be probably easier than for week one or two. That's the hope. Okay. Any other questions?
For the midterm exam, will you still have your normal office hours on Thursday?
Oh, great question. And yes, but you might have noticed, and let's see if I could make sure, quote, normal office hours on Thursday. Actually, this Thursday, yes, I'll be having office hours like Thursday before this class, and then also before the afternoon class as well, not the Thursday later time slot. And I don't have any office hours booked for Friday, but you can let me know via email if you need to. I will be on a plane Friday afternoon, and so the airport might be challenging, but well, waiting for boarding before 3 p.m., I'm probably going to be okay to sort of jump into a Zoom meeting real quickly. If you do have a question, just make a request.
Okay, thank you.
Okay, so I'm not hearing another question, but I'm also not needing to go. Do want to note, though, if I were you, I would probably look at uh the 2023 review before their exam. Indeed, it's the um exact same review questions as you guys are having. And that's really the reason it's the exact same review or sample exam questions is because there's videotapes of people in the past asking questions. I think that's really good to have as a resource. So it's the same sample exam as a few years back, but hey, that's good because you guys can benefit from looking at that as well. So if there's no other questions, I'm just going to stop the share and hang out for a few more minutes. But I'm going to turn off also the recording unless one of you requests that I not.
Thank you, Professor.